Hello friends, myself Pratibha Rondal, Department of Chemistry of KANMS ACS College, Satana. Today I am going to discuss about introduction of stereochemistry. Make sure you have chiral center in the molecule. The fact that a three-dimensional formula is given that does not imply that there are chiral centers. First of all, we have to assign the priorities to the atoms directly attached to the chirality center. The highest priority goes to the atom with the highest atomic number. In case there are isotopes, use the mass number instead since they have the same atomic number. Today we discuss about the RS nomenclature system, that means can in called Prelog convention. Here Cl, hydrogen, methyl and NH2 group is there. Here Cl carries the first priority, NH2 carries the second priority and the methyl carries the third priority, and the hydrogen atomic number of hydrogen is too much less, so it carries the fourth priority. So here we have to apply the Prelog rule, and after that we orient that molecule, then we will get the configuration. If the two or more of the atoms directly attached to the chiral center are of the same type, look at the next atom to break the tie. Do not do this unless there is a tie. Repeat this process until the tie gets broken. It is important to emphasize that in trying to break ties, one look at the atoms directly attached to the element under the observation before looking at any others. Here there are different examples in that on the basis of the atomic number we give the priorities: first priority, second priority, third priority, fourth priority. The atomic number is very much less, at that time we give the priority here less, and the atomic number is higher, then we give the priority is the higher. By applying this rule, we orient that molecule. If there are atoms containing the double or triple bond, count them twice or thrice respectively. This holds for each of the atoms involved in the double or triple bonding. Here carbon, double bond carbon is there, hydrogen is there, methyl is there, and the ethyl is there. So atomic number, when we compare the atomic number of methyl and the ethene, so the CH2 CH3 having the higher atomic number as compared to the CH3, so we give the second priority to the CH2 CH3 and the third priority to the CH3. Here a bulky group is there which carries the first priority, and the atomic number of hydrogen is less, so we give the priority number 4. According to Kahn-Ingold Prelog convention, when assign absolute configuration to the chiral carbon, the lowest priority group that attached to the carbon must be pointing away from an observer who is looking at the carbon in question. On the paper, that usually means that if the observer is the person looking at the page, then the lowest priority group is pointing away from the observer and the going behind the plane of the paper. That means in 3D formula, this indicates that with the lowest priority group position in front of the rather than towards the back, the central carbon appears to have the R configuration. The actual configuration is there for us. This best seen when we rotate the molecule until the hydrogen is in the correct orientation. This is the example. Here the chiral center, no chiral center present. In the second molecule, here chiral center is present, having the 1, 2, 3 priorities is given, and the configuration is R configuration. This is the possible combinations of the 2,3 dibromobutane. Here butane is there at the position number second and third. We have here seen the Br atom, that's why the name is 2,3 dibromobutane. Here the possible combinations are there. First form is the mesoform, that means here same. When we compare that structure, here the diastereomer is also there and the pair of enantiomer is also formed. This is all about the possible combination for the 2,3 dibromobutane. When we compare the second and third number structure, at that time this is the diastereomer. When we compare the first structure and the fourth structure, at that time this is also pair of diastereomer. When we compare the structure number 1 and 2, at that time this is the mesoform, that means the same. When we compare here the structure number third and fourth, at that time this is the pair of enantiomers. Thank you.